So for material prep for MIG, MIG is a pretty dirty process, so it can go through a lot of like grossness on your pieces. For my students specifically, I like to clean up the pieces because let's try to rule out what is the material being dirty from what is the student, from what is the machine potentially. So just less variables if we clean it up and we make the pieces really nice. So for starters on that, we're gonna go ahead and use an angle grinder and just touch all the edges just to make sure that we get off any scale or anything that's kind of in between there or any imperfections. The next thing is that if we were in an industry, we probably put bevels on our edges here. I will demonstrate how to do a bevel with an angle grinder, but for my students at Hardy and Fuller, we don't really focus on it just because we're focused more on the ability to weld versus like welding with bevels. So to get started, we're gonna go ahead and use our angle grinder. So I'm gonna go ahead and hit all of those edges just with a quick sand. We're using a flap disc here. I believe it is 40 grit. It's a little bit used, but should still do the job. Let's talk about using an angle grinder. So there's a few safety precautions that you're gonna wanna always make sure of. The angle grinder can be a really scary tool, but it doesn't have to be if you use precautions. So first off, you're gonna always wanna wear safety glasses. Make sure they're shatterproof, make sure they're up to ANSI safety standards, make sure you have those on. Our second thing is going to be we're going to use gloves for this process. So any sort of gloves that just protect your fingers. Again, if they have an ANSI cut warning on them, that is always a better thing than not. We're going to go ahead and use these driver gloves right now just to protect our fingers. The last thing we're going to do is it's always a smart idea to clamp down your material just so that it's not flying all over the place on you. You can also grind bevels in a vise if you have it, but using a clamp to make sure that that material just doesn't move as you're grinding it is super important. So we're gonna go ahead and clamp that down as well. So that's one piece done. We're gonna go ahead and do the second piece. Now, if y'all notice, my angle as I'm grinding, I change it a little bit as I go. The sharper your angle, the more material you're gonna take off of your pieces, and the lighter your angle, the less material you're gonna take off of your pieces. So if you notice, my angle is a little bit sharper as I go over the edge just to take some of that material off. But then as I go over the top to just make sure there's no burrs, I keep a nice flat angle. So that does kind of make a difference. So try to keep that in mind as well. Keep in mind your pieces might be a little bit hot. Remove everything else from your workstation that can get sparks on it. And then we are going to clean these pieces up even a little bit more. Again, this is not totally necessary. For my students, I clean the pieces with acetone to just make sure that there's nothing left on them to potentially get in the way, cause porosity, cause an issue. I want to really figure out what is the student and what do they need help with. And then what is the material. So we're going to clean it up a little bit more right now. So for cleaning with acetone, this is a bottle of acetone. We're going to go ahead and spray these pieces down. Feel free to use as much as you need. And then this is just a Scotch-Brite pad. We're going to go ahead and give them a nice rub down. Some things in the metal may not come off with the acetone. So for example, things that are a little bit deeper in, things that might be a little bit rusted or what have you. Again, MIG is a pretty dirty process, so there's really no need to go in with like a grinder and get that stuff off. If this was TIG, I would say yes, let's go ahead and get that off. But for MIG, just cleaning it with the acetone is plenty. So again, acetone, no acetone, we're gonna go ahead and do that other side. Perfect. When we're thinking about material prep in the field for welding or other things that you may come across, So paint is a big thing. I would say rust is also probably a big thing. With paint, so you can't weld over paint with any of these processes. You're going to want to remove all of the paint. Same thing with your ground cable. If you were doing a job on somebody's fence or something per se, and the fence is all painted black, you are going to want to remove an area to put your ground clamp on that is just bare metal. So how you would do that, you could either use the same flap disc that we were using. A wire wheel can be another tool that is helpful for removing paint, although wire wheels are also a little bit honestly scarier, for lack of a better term. There are specific discs that remove paint. If you're using a wire wheel, you need to make sure that you have like a face shield on. Just use correct PPE with that, because those wire strands can come out after a while of using that wheel. So yeah, either a specific one for paint removal, a wire wheel with correct PPE, or a flap disc. The flap disc is going to take off the most material. Really, you don't want to take off the steel, you want to just take off the paint. So that's where the paint scrubbing disc can be really helpful. They can be a little bit more expensive, but very helpful nonetheless. And it is super important to remove paint. As far as rust goes, if it's something that you're like replacing because it's so rusty that it's falling apart, having clean edges that you're kind of welding into is important, so cutting that rust back so that it's not there anymore. If it's just surface rust, again, using the same thing, so a wire wheel, a flap disc, and being really careful about your angle, so a nice flat angle to make sure that you're not taking off very much material, you're just taking off the rust. Or again, something that's a little bit harder, like those paint scrubbing discs, just to try to get some of that surface rust off so that you're not going and welding on top of that as well. Let's talk about galvanized stuff. So galvanized stuff is typically covered in a zinc coating to prevent it from like rusting and things like that. That galvanized coating is really bad for you to breathe in as you're welding it. It comes from the zinc, so heating up the zinc can give you something called zinc poisoning, which is not what you want. So if you are welding galvanized and there is no way of getting around the galvanized, you need to wear a respirator at like a bare minimum. Again, up to ANSI safety standards, you need to be wearing like a good respirator with a tight fit, that you are not inhaling that zinc once the fumes are coming off, once they get hot. If you're in a situation where you can remove the galvanized coating, you can soak it in like a muriatic acid to rust it and then take that rust away, but it'll eat through the galvanization and that coating that's on it. You can also, again, using kind of the same methods that were mentioned, try to like sand off or grind off the zinc coating. It's not a super thick zinc coating, it's just on it and ever present, so you need to get it off. But yeah, welding galvanized is really bad for you. Definitely take care of yourself, wear the correct PPE, and try to avoid it if at all possible. My best advice for welding galvanized is just don't do it. Outside of that, so steel is magnetic. If you're welding something, again, let's say you're welding somebody's gate and you're not sure if it's steel or if it's stainless or if it's cast or what have you, using a magnet can be really helpful. If there is a part of that project or something that you can take off or take home and do a grind test on it, that can be really helpful because different types of steel have different sparks, different materials have different sparks. So that can kind of clue you into what type of material it is. With stainless steel and aluminum, they won't be magnetic, so that can be a really easy way of telling you, hey, it may look like steel, but something's up. So using a magnet, doing a spark test can be very helpful, but make sure that you know what material you are welding before you start welding, because MIG welding, for example, doesn't work on cast iron. So it might actually affect the job that you're doing or your success rate in doing that weld. One other thing that I am thinking of in the moment, since we're talking about doing jobs and potentially being outside, is if you are outside, it is common practice to kind of increase your gas rate a little bit, especially if it's a breezy day, just because your gas is going to be flying all around and you want it to protect your weld. So that's one thing, just last, that I was kind of thinking of. Otherwise, get out there, have some fun, and good luck welding.